Today we are going to be looking at an easy way to write balanced equations. So we have a chemical reaction that can be described uh, as starting with the reactants solid potassium, water, and then these are going to produce hydrogen gas and potassium hydroxide in an aqueous solution. So what we know about chemical reactions is that atoms are not created or destroyed. So we can already see here that this is not a balanced reaction because we have 2 hydrogen here and we have 3 hydrogen on the product side. So it's not balanced, so we have to fix that. So a really nice way that I like to work with these kinds of equations is to just go ahead and write down your atoms, and we're going to focus on just the number of atoms for the reactant side and the product side. So we can see here that on the left side we have 1 potassium, and we have 1 oxygen and 2 hydrogen on the reactant side. On the product side, we have 1 potassium, 1 oxygen, and 3 hydrogen. So we know that the multiples of hydrogen is 2 on the reactant side, and the multiples of hydrogen on the product side is 3. So the only way to balance those out then is to multiply them by each other. So now in doing this, we have to make sure that we do each side and decide which molecules we're going to multiply. So here on the product side, I know that in order to get 6 hydrogen on both sides, I need to multiply or double the hydrogen. So I would prefer, because this is an even number, this is 6, I would prefer to just multiply the hydrogen gas by 3 and be done with it. But unfortunately, 6 is an even number, and there is no way that we can get an even number with an odd number of hydrogen hanging out here in this potassium hydroxide. So that means I'm pretty much forced. I know that I have to get an even amount of hydrogen atoms, so I know I'm going to have to double both of these. And so then I have 2 hydrogen gas, which gives me 4, and then 2 hydrogen here, which gives me 6. So that's balanced here. And now we are going to look and see how that has affected other atoms. Since I've doubled hydrogen potassium hydroxide, I have also doubled the amount of potassium and the amount of oxygen. So in balancing my hydrogen, I now have imbalanced other atoms, and that's just how it goes. So now we have to go back to our reactant side and make sure before we do anything else, we have to reflect this 3 here. So we said we had to triple the amount of hydrogen. Well, luckily I only have one choice for tripling hydrogen here. Only one molecule contains hydrogen. So I multiply my water by 3, my water molecules by 3. And in doing so, then I find that I only affect the oxygen by multiplying it by 3. So if we look at the product side and the reactant side, what we're seeing so far is that now our oxygen is out of balance. There's really nothing we can do about that. We just have to go ahead and double that and then triple the other side, just like we did for the hydrogen. For the potassium, I'll just go ahead and multiply this by 2 on the reactant side because it's easy. because my potassium is isolated by itself in a solid state. So it's pretty easy to just double that. It's not going to affect anything else besides potassium. Okay, so now we go ahead. We're going to take a look. Let's just start with the reactant side this time. We got to make sure we do both of them though. So let's take a look. I want to double my oxygen. Okay, so my only choice in doing that is doubling the water. And in doubling the water then, rather than 6 water molecules, or rather than 3 water molecules, I now have 6. So there's 6 there. And let's see, so we have 6 oxygen, awesome. And now we have 12 hydrogen, because I have 2 hydrogen atoms here. So that is 12 total. Okay. And now, that looks like that reflects all the changes that we've made by doubling the hydrogen here. So let's take a look at the other side. So now we have to go ahead and make sure that we triple our oxygen. So in tripling our oxygen, the only way to triple it is to triple our potassium hydroxide. So we're going to do that. So 2 times 3 is 6. That's tripling our potassium hydroxide. So now we have 6 oxygen atoms, and now we have 6 potassium as well. So we have to reflect that. And now we have 6 hydrogen here. And we also have 4 here. So that means that we have a total of 10. And let's just go ahead and write down 10. So that's 2 times 5. Okay. Right. And so let's take a look at the other side. So what do we need to do to balance this one more time? Well, rather than just looking at, well, I have 2 times 5 here, and now I have 2 times 3 times 2, so I have to get, the multiples to match up. We don't have to, because in this case, if I want to get 2 more hydrogen in order to get 12 hydrogen here and 12 hydrogen here, well, luckily I have an isolated hydrogen gas here, which has 2 atoms of hydrogen. So I can just multiply this, increase this multiple by 1. And that's going to give me my 12. So that balances out, which is really convenient. And it also doesn't change anything else. So then let's take a look. The only thing left is we need to balance this potassium. And that's also easy, because then I can just multiply that by 3. And that gives me 6. Okay. So let's go ahead and do a count on both sides real quick. So we should see 6 here. We see 6 here on the reactant side. For oxygen, we should see 6, and we see 6. For hydrogen, we should see 12, and we see 12. Okay, so that's matching up well. Now let's take a look over here. So for potassium, I have 6, so that's good. For oxygen, I should see 6, I do. And then for hydrogen, I have 6 here and 6 here, which gives me 12. So this is now a balanced chemical equation. And the other thing that we would want to do in this case is, because it's an equation, And because we know that the amount of atoms on the left side is equal to the amount of atoms on the right side, we can take a look at what we have here. We have multiples, common multiples in the molecules of the reactants and the products. So just like with an equation where if you have, 3 times 3a plus, 6b is equal to 6a plus 3b, you have common multiples here of 3. So I could divide both sides of this equation by 3, and that would be equivalent to saying a plus 2b is equal to 2a plus b. So you should go ahead and put it in the reduced form, which just means dividing by the common multiple because it's just easier to look at. And if you're trying to sort of make things simple, then that's what we want to do. So let's go ahead and we're going to divide everything by 3. So that means we have 2 solid potassium reacting with 3 water molecules. And that's going to produce for us 1 hydrogen gas and 2 potassium hydroxide in an aqueous solution. So this is the way that I like to work with balanced equations, or to make an unbalanced equation into a balanced one, because you can kind of see a little bit like the history, and you're not just constantly rewriting the molecules over and over again. Yeah, and I hope that's useful.